네, 오늘도 사이언스 클래스 라이브를 함께 해주시는 시청자 여러분들 반갑습니다. 진행을 맡은 한국과학창의재단의 노성찬입니다. 네, 4월 마지막 주 사이언스 클래스 라이브는 탄소 중립을 주제로 진행됩니다. 지난 4월 19일 TVN에서 방영된 미래 수업은 탄소 중립을 주제로 진행하였습니다. 기후변화가 인류에게 미치는 영향과 다양한 현황을 소개하였는데요. 어제는 특별히 두 분의 연사를 모시고 이러한 내용들에 대해 조금 더 디테일하게 소통해봤습니다. 글로벌 현황과 우리 사회는 어떻게 준비하고 있는지에 대한 거시적 내용은 유영숙 기후변화센터 이사장님과 나누었고요. 글로벌 에너지 전환과 에너지 기술의 현황에 대해 곽지혜 애기연 재생에너지 연구소장님과 소통해 보았습니다. 오늘은 기후변화와 관련된 세계적 석학과 소통해 볼 예정입니다. 세계 논문 피인용 상위 1위로 클래리베이트 애널리틱스가 선정한 세계 가장 영향력 있는 연구자로 선정되셨으며 유럽 지구과학 연맹이 지구변화 및 모델링 분야에서 탁월한 업적의 우수 연구자를 선정해 시상하는 밀루틴 밀란코비치 메달 수상자이시기도 합니다. 오늘은 강연자 이름은 IBS 악셀 팀머만 기후물리연구단장님과 함께 할 예정입니다. 기후변화에 대한 영향을 설명할 수 있는 강의는 상당히 많이 만나보셨을 겁니다. 지난번 방송을 포함해서. 근데 기후물리학자로서 과학적 지식과 연구 경력을 바탕으로 이렇게 깊이 있는 강연을 나눌 수 있는 시간은 그렇게 흔치 않을 거라고 감히 말씀드리고 싶습니다. 오늘은 강연의 좀 특성상 질의응답은 강연이 진행되는 중간에 유튜브 채팅방 실시간으로 남겨주시면 질문 내용을 선정해서 사후에 이제 질의응답 시간에 답변 드리기로 하겠습니다. 그래서 강연을 보시면서 궁금한 점은 바로바로 그 채팅방에 남겨주시면 되겠고요. 또 마지막으로 오늘의 강연료는 악셀 티머만 교수님께서 요청에 의해서 기후 변화에 유의미하게 기여할 수 있는 단체에 기부해달라고 요청을 좀 주셨습니다. 그래서 한 명의 개인으로서 교수님의 열정과 소명에 굉장히 존경하고 감사드린다 말씀을 드리고 싶고요. 좋은 기부처를 찾아서 기부 드릴 수 있도록 처리하겠습니다. 그리고 그 강연에는 번역해서 자막이 나갈 예정입니다. 보시다가 다소 오역이 있을 수가 있는데 너른 양해를 좀 부탁드리고 오늘의 강연 지구온난화와 탄소중립을 주제로 IBS 기후물리 연구 단장님이신 악셀 팀머만 교수님의 강연을 시작하도록 하겠습니다.
Good evening to you all. My name is Axel Timmermann and I'm the director of the IBS Center for Climate Physics at Busan National University. The talk today is about decarbonizing our planet. Why and how? And as a climate scientist, I will mostly talk about the why. And later on, if there is time, I will talk about how. So let's talk about the why first. Why carbon neutrality? Fossil fuel burning releases greenhouse gases, mostly CO2, which causes global warming and ocean acidification, and the so-called ocean hypercapnia. But as we know, fossil fuel burning is also a large contributor to air pollution. We should keep in mind that the fossil fuel that we are burning today will stay in the atmosphere for a very long time. What we are burning today will stay in the atmosphere for thousands of years. For example, when I go home tonight back to Busan, the KTX will use electricity. Electricity will come from a power plant. The CO2 that is emitted into the atmosphere will stay there for up to 2,000, up to 10,000 years. So we are creating a very long-term carbon legacy on our planet. Let us begin our discussion today with the issue of global warming and a famous quote. It's time to stop waffling so much. The greenhouse effect is here and affecting our climate now. This quote is from a famous climate scientist, Jim Hansen, and it is from 1988. 31 years later, we are still waffling. Global warming will have major impacts on our lives. Changes in extreme events can lead to loss of property and lives. Global warming causes also sea level rise, which means lots of people on our planet will lose their long-term home. Some of the Pacific Island nations will actually lose their home country. Global warming will exacerbate food insecurity, which will lead to famines and loss of lives. Furthermore, global warming already has a major effect on ecosystems, which presently already causes massive loss of biodiversity, such as, for instance, in coral reefs and other ecosystems. How does global warming work? The physics is very simple. It's the physics of the greenhouse effect. Without greenhouse gases, our planet would be much colder. The incoming sunlight would warm up our planet, infrared radiation would go out, and our planet would find a balance where the incoming solar radiation and the outgoing infrared radiation start to balance. This would be at a temperature of about minus 18 degrees Celsius. Now, we have a normal level, a normal concentration of greenhouse gases in our atmosphere. This means that the incoming sunlight again will start to warm the planet, but the greenhouse gases have the property that they can partly absorb some of that infrared radiation, and then they emit a part back to space and part back to the surface of the planet, which makes the planet's surface warmer than otherwise. Now, what we do is through our industrial activities, we are enhancing this natural greenhouse effect. We are putting more greenhouse gases into the atmosphere, so more of the infrared light that actually wants to escape to space will actually be sent back to the surface of our planet. So global warming is nothing else but an amplification of the natural greenhouse effect. So with this amplification, our planet can get significantly warmer, and we will see that later on. As the atmospheric CO2 concentrations have definitely increased over the last 150 years due to the industrialization, there should be a clear warming. And in fact, we do see the warming. Over the past 150 years, our planet has warmed, as illustrated here by this so-called warming stripe graphic. Blue means cold, red means warm. The Intergovernmental Panel on Climate Change stated in 2013, the warming of our climate system is unequivocal, and since the 1950s, many of the observed changes are unprecedented over decades to millennia. For Korea, we see a similar trend of about 1.8 degrees Celsius over the last century, with about 35% coming from urbanization, 65% from the greenhouse warming effect. But to fully understand this graphic, we should also try to understand the individual stripes in this graphic. We need to consider our sun is a variable star. It changes its output every 11 years. There's a so-called solar cycle. And this has some influence on the radiation that our Earth actually receives, solar radiation. But it turns out these fluctuations in the solar output are relatively small, so they have essentially a negligible effect on the global surface temperature. Very small. And none of these stripes here can be really related to the solar variability. There is another factor. Some of these cooling stripes that you're seeing are actually related to volcanic eruptions. Volcanoes spew large amounts of sulfate aerosols into the atmosphere, which dim the sunlight. That means our planet cools down by about 1 to 2 degrees Celsius for very strong volcanic eruption. But this cooling only lasts for about 1 to 3 years. So volcanic effects are only temporary and can explain some of these stripes in here, not all of them. So some of the warming stripes, in particular this one and this last one, they can be related to the El Nino Southern Oscillation phenomenon. This is a naturally occurring climate event which takes about 1 year and warms up the tropical Pacific by about 3 degrees Celsius. And you can see this effect, this event also in the global surface temperature, such as, for example, here in 2016. Again, this is only a temporary effect. In order to understand the long-term shift from blue to red, we really need to think about the other forcings. This is the increase of atmospheric CO2 concentrations, which has a warming effect on our planet. And we need to take into account also the fact that through industrialization, some of the aerosols were emitted into the atmosphere, which can also have a cooling effect. But it turns out over the last 50 years, the CO2 contribution has been the dominant source for global warming. In this animation, you just saw the warming of our planet for the last 150 years. Now, seeing the situation in 2020, we can clearly identify the oceans are warming less than the land, and the Arctic region is warming fastest. Well, that makes sense. The land warms faster than the ocean because there is less heat capacity on land. The ocean can absorb a lot of the heat that it receives from the atmosphere. And that plays also an important role, as we shall see later, for the sea level rise issue. How can climate scientists predict the future? How can they predict the future of the next 100 years or 150 years? This sounds a bit strange because we know we can predict the weather only about 1 or 2 weeks ahead. How can climate scientists predict the climate hundreds of years ahead? Well, first we need to keep in mind weather is not climate. Climate scientists are not weather forecasters. So what is very important to note is that in order to understand the climate system, we need to consider the atmosphere, we need to consider the oceans, the vegetation, the sea ice, land, the chemistry of the atmosphere, the radiation of the atmosphere. So there are many, many different components. Each of these components has a set of mathematical or physical equations. If we put all of these equations together, they would fill the entire room if I just wrote them down with a pencil. So these equations are so complicated, you cannot solve them by hand. You cannot solve them even with a normal computer. What you need is a supercomputer. And climate scientists are using some of the fastest supercomputers in the world in order to solve these complicated equations. And here you can see a little animation of the installation of our supercomputer that we designed and purchased together with the IBS headquarters. The machine is called Aleph, the first letter of the Hebrew alphabet, and it is installed at the IBS headquarters center in Daejeon. It is one of the fastest supercomputers in the world that is mostly dedicated for high-performance climate modeling. And what you can see here are some of the visualizations, for example, of ocean surface temperature, ocean currents, the sea ice, and also tropical cyclones that come from these enormous computer model simulations that we conduct. the computer is able to do 1.5 quadrillion calculations per second. And it creates enormous amounts of data which need to be stored in extra computer systems in the back. This shows an animation or visualization from these supercomputer data of the ocean currents. You're seeing here very strong currents. This is a north equatorial countercurrent. This is the Kuroshio current, which brings warm water towards Japan. You see lots of small-scale ocean turbulence and structures. Every once in a while, you see even the effect of a tropical cyclone spinning up the ocean circulation temporarily. So this is the level of detail and the types of scales that we are simulating with these computers nowadays. And this is done globally. I'm just showing a small snapshot here. This is another visualization where we see in red the wind speed, and in white you see the main rain bands that surround these tropical cyclones that form and go towards Japan and Korea. Again, this has nothing to do with the real observations. This is all coming out by solving the mathematical equations in our computer. And what you're seeing here is just about 2 months of data. Keep in mind, we run these simulations for hundreds of years on our computer so that we can adequately determine how changes in atmospheric CO2 are going to influence these tropical cyclones. And I will talk about it in a minute. When we increase the atmospheric CO2 concentration in the computer model, a doubling, the effect is very clear. We see massive warming, in particular in the Arctic area, up to 10 degrees Celsius for a doubling over the next 80 years. We see a warming over Korea of about 4 degrees Celsius. We will talk later what that actually means. Now, if you continue this doubling, let's say over the next 130 years, the planet will warm even more. The Arctic will warm up to 15 degrees Celsius. Korea will experience temperature changes of up to 8 degrees Celsius in the annual average. So this is a lot, and this really illustrates the power of the greenhouse effect. In terms of rainfall, the computer models predict that some areas will get wetter, and other areas, such as Korea, for instance, other areas will get drier. And I'm highlighting here the Mediterranean region in Europe, which is projected to experience a massive drought, rainfall reduction throughout the entire year of 25% for a CO2 doubling and up to 40% for a CO2 quadrupling. This would have massive changes for people's livelihoods, farming, drinking water supply, etc. Unless we cut down the CO2 emissions as a result of carbon neutrality. As mentioned already, global warming can change also extreme events. Here I would like to share with you our latest results that demonstrate how unabated CO2 emissions can impact tropical cyclones. Using the Aleph supercomputer from IBS in Daejeon, in some of the most realistic global warming simulations conducted to date, we found that by increasing the atmospheric CO2, the overall number of tropical cyclones will decrease. You can see that tropical cyclones of category 2 and less will start to decrease. However, the number of strong tropical cyclones will increase. That is very important for infrastructure planning. Moreover, every tropical cyclone in future will be associated with much more water vapor and rainfall. For a CO2 doubling, a normal tropical cyclone will bring about 15% more rainfall. for a CO2 quadrupling over the next 130 years, it will be up to 40% more rainfall. So flooding will become much more extreme from these tropical cyclones. Heat waves is another type of extreme event that we should really pay attention to. It causes physical harm to people who are exposed to outdoor heat. In this graphic, you can see how the daily maximum temperature will change over Seoul according to our computer model simulations. Currently, we only have very, very few days that the temperature can even exceed 40 degrees maximum. However, as we increase the atmospheric CO2 concentration over the next 80 or 150 years, we will see the number of days above 40 degrees Celsius will increase dramatically. In fact, you can say that today's worst heat wave will become the future summer norm unless we reduce CO2 concentrations. The worst heat wave, as I mentioned, will become the normal future summer day. And we really need to decarbonize our planet in order to stop this. These changes in heat waves will have severe impacts on our livelihoods, as you can imagine, on agriculture, energy consumption, and outdoor labor. I also wanted to discuss with you briefly the effects of global warming on sea level rise. The oceans will take up some of the global warming heat, as I mentioned before, and as a result, the ocean water will expand. This leads to sea level rise. Furthermore, we have the major ice sheets, Antarctica and the Greenland ice sheet. They start to melt and slowly, gradually disintegrate, which contributes to the sea level rise. This second part of the sea level rise has been very, very difficult to estimate. But I would like to share with you some of our latest results from one of our PhD students in our center, Junyoung Park, who conducted simulations with a coupled climate ice sheet model. And these simulations show that if we look at the contribution from Antarctica and Greenland, the major ice sheets, over the next 10, 50, 150 years, what we will see is that over the next 80 years, the Antarctic and Greenland ice sheet will contribute about 50 centimeters to global sea level rise. Together with the thermal expansion, that's going to be about a meter. Okay, so over the next 130 years, the story is different. The thermal expansion of water will already be 1 meter. On top of this, we will have about 150 centimeters of water in our oceans in terms of sea level height that will come from the ice sheets. So the total sea level rise would be 2.50 meters approximately. So this is a very, very important number because 2.50 meters or even 1 meter will put a lot of coastlines, a lot of communities, coastal communities, under pressure. They will first start to see that the groundwater will get salty. They will see that crops, agriculture will not grow anymore because the water is too salty. Later on, there will be inundation, waves, storm surges taking away essentially land. So the massive sea level rise that we project with our computer model simulations will change communities, harbors, cities, beaches, wetlands, ecosystems, etc. That is, if we don't cut down CO2 emissions dramatically. As one of the last examples of global warming impacts, I would like to talk about the effect of global warming on agriculture and food security. According to recent studies, due to global warming, many crops will experience temperatures far beyond their normal range. This leads to a drop in productivity. And we know that for future warming of about 1 degree Celsius, we can expect a reduction in the global productivity, agricultural productivity, of about 10%. If we don't cut down CO2 emissions drastically, our planet will warm up by another 3 degrees Celsius over the next 80 years, which means global food production will drop by 30%. And that will happen at the same time as the world population continues to grow. And you can imagine this will cause massive famines and starvation and migration. As we increase atmospheric CO2, part of this CO2 will be taken up by the oceans, where it causes a chemical reaction called ocean acidification. How does it work? First of all, ocean acidification will lead to a loss of ocean habitat, loss of biodiversity, and it will also cause food insecurity for us because we are currently taking a lot of proteins from the oceans. The reaction, chemical reaction, is very simple. We have in the ocean a calcium ion. That calcium ion finds a carbonate ion in the ocean to form calcium carbonate. This is what we see, the little shells, oysters, corals, they're all made out of calcium carbonate. However, as we increase the atmospheric CO2, part of that atmospheric CO2 will be taken up by the ocean, about 30 to 40%. That reaction hijacks the carbonate ion, and what you're getting is a bicarbonate ion. But this reaction cannot take place anymore, which means essentially we cannot build chemically calcium carbonate so easily. And that will have major effects on biological organisms in the ocean and on the entire food web. This can also be easily seen in this little illustration. On the left-hand side, you see a little snail, a pteropod, which has a calcium carbonate shell. And here this is for normal CO2 concentrations. And here you see the same pteropod exposed to much higher CO2 concentrations. And you can see it has holes, it is brittle, it is feeble, it can't move anymore. So it will be actually not very easy for this pteropod to swim and to survive. So this is an illustration how a simple chemical reaction that involves the CO2 that we are blasting into the atmosphere, how this chemical reaction can change life on our planet. What I just said is all bad news. However, there is some good news. The future outcome is still in our hands. No action means hotter planet, much more severe ocean acidification. If we act now, swiftly and forcefully implement carbon neutrality, we can reduce the impacts considerably and leave the world a better place for our children and grandchildren's generation, with reduced warming, reduced sea level rise, and reduced ocean acidification. Given that what we have discussed before, it is clear we need to decarbonize our planet as soon as possible. And let me be honest, this is not going to be a small task. But it is absolutely crucial for the future of our planet and our civilization. But how? First, it is important to realize that there are a lot of positive effects of decarbonization. we will, number one, we will reduce climate damages to our society and ecosystems. Number two, we will reduce air pollution substantially, which is a killer in Asian societies. We will reduce our dependence on fossil fuels. And number four, through the energy transition that is required in order to become carbon neutral, we will create a new green economy. It's a win-win-win situation. The Paris Agreement was an important milestone to guide the world community into the right direction. The Chinese have pledged to limit global temperature rise to well below 2 degrees Celsius, while pursuing efforts to limit it even below 1.5 above pre-industrial levels, which is above the level of 1850. But please keep in mind that we've already warmed our planet by 1 to 1.1 degrees Celsius. So we are very close to reaching this 1.5 mark already. From a climate scientist point of view, the Paris Agreement is just the first step. It is not enough to avoid dangerous climate change. More detailed implementations, more aggressive steps are necessary. South Korea's total greenhouse gas emissions ranked number 11 worldwide, and only 6% of its energy production comes from renewables, as compared to 46% in Germany. Currently, South Korea's greenhouse gas emissions amount to about 700 million tons of CO2 equivalent, with the largest contribution coming from the power and industry sectors. In December 2020, the South Korean government pledged to become carbon neutral by 2050. This is an ambitious but absolutely necessary goal. It is ambitious in that one has to essentially replace the entire energy sector by alternative resources within the next 30 years. And number two, we need to save energy massively. These are the two big ticket items. Emission trading, carbon capture, reforestation, okay, they can temporarily cause some relief, but they will not be efficient in the long term. South Korea's National Determined Contributions, NDC, the target, is deemed by experts to be totally insufficient to even fulfill the Paris Agreement's pledge. With only 2% of the current energy coming from wind and solar, Korea needs to implement renewables quickly, which probably means major restructuring of the energy management sector. As I said, in addition to replacing the current energy generation by renewables, saving energy and thus reducing CO2 emissions will become one of the largest pillars of carbon neutrality. In fact, we need an energy saving and an efficiency revolution in this country. To accomplish this, one needs a multi-pronged approach in which energy is used in smart ways, smart cities, smart transportation, smart factories, in our daily lives, in the public and governmental and industrial sectors. We need clean and environmentally friendly energy storage, for instance, through hydrogen fuel cells serving as batteries to stabilize the electric grid. Moreover, to change consumers' behavior and penalize the use of fossil fuels, a combined economically friendly carbon tax and dividend system should be introduced. A carbon tax would be imposed for carbon emission products. The government-collected tax would then be released as subsidies for the clean energy sector, and partly paid back to the society as a bonus at the end of the year. So the combination of tax and dividend is important to keep it economically neutral. Environmental scientists have demonstrated that one can reduce the carbon footprint of an entire city with existing technologies by a factor of 4. This graphic shows just some ideas how we can reduce carbon emissions in our daily lives. These include eating local, eat less meat, use fuel-efficient transportation, improve building insulation, take shorter showers, dry your clothes naturally, use recycling papers, don't invest in Bitcoin, use solar energy, use a solar heater, etc. So there are many ways how we can personally contribute to a path towards carbon neutrality. Let me summarize. To avoid dangerous climate change, sea level rise, and ocean acidification, all of which are caused by fossil fuel burning, we need to cut down our CO2 emissions as quickly as possible. This will not be an easy transition. But the good news is that many other countries will do exactly the same. Through dedicated domestic efforts and international cooperation, South Korea could become a global leader in developing and exporting new technologies, such as, for example, for energy storage, to the growing international decarbonization market. But one of the first priorities for South Korea should be to massively increase the ratio of solar and wind in the total power generation. Only then can carbon neutrality come within reach. Thank you for your attention.
네, 강연 잘해주신 악셀 티머만 교수님께 박수 부탁드리겠습니다. 네, 그러면은 다음으로는 그 질의응답 받아놓은 걸로 이제 넘어가겠는데요. 사전에 일단 두 분의 질문을 좀 받았습니다. 일단 이영희님 연결 가능할까요?
안녕하세요. 교수님, 여보세요. 교수님 강의 잘 들었습니다. 제 질문은요, 다른 나라의 탄소 중립을 위한 태양, 풍력 등의 신재생 에너지에 대한 국가적 제도 및 제도적 기반은 어떻게 마련되고 있는지 궁금합니다.
South Korea's current pledges to reduce CO2 emissions are insufficient to reach carbon neutrality by 2050. But it's also important to note that Korea is about 20 years behind in terms of introducing solar and wind into the electric grid as compared to many European countries. The European Union has pledged to reduce CO2 emissions by 2030 by 55%. South Korea is nowhere close. The main goal should therefore be to heavily invest in winds and solar. And following the example of the European Union is a good path forward. There is no reason to reinvent the wheel.
네, 답변 감사드립니다. 지금 말씀드린 거는 이제 자막으로 표시가 되었으니 확인해 주시면 되겠고요. 다음으로는 최민재님 연결해 보겠습니다.
네, 안녕하세요. 강의 정말 잘 들었습니다. 제가 IBS 슈퍼컴퓨터 알레프를 통해서 대기 중 이산화탄소 농도가 증가하게 되면은 이제 강한 태풍이 발생한다는 그런 예측을 하는 기사를 본 적이 있는데요. 이산화탄소 말고 또 이렇게 기후 변화에 큰 영향을 끼치는 요소가 어떤 게 있는지 궁금합니다.
In addition to CO2, there are also other greenhouse gases, such as methane and nitrous oxide. But their contribution to the overall warming of these two is relatively small as compared to the CO2-induced greenhouse warming effect. So nevertheless, reducing methane emissions is a very good step.
네, 답변 감사드립니다. 지금까지는 이게 줌을 통해서 이제 준비된 질문이었고요. 그리고 이제 지금 답변도 남은 건가요? 네. 그 다음은 이제 유튜브를 통해서 접수된 질문을 답변 드리도록 하겠습니다. 박지환님, 탄소 중립을 간단 명료하게 한 문장으로 요약하면 뭐라고 아이들에게 설명하면 좋을까요? 그리고 아이들에겐 부모의 말보다 선생님의 당부가 더 의미 있고 전달력이 큰데요. 아이들의 시점에서 어떻게 했으면 좋겠다라고 한 말씀 부탁드립니다. 네, 이거에 대해서 이제 답변 주시면 되겠는데요. 그 답변을 넘겨주세요.
It is more important that our generation does something right now, because we are leaving a heavily altered planet to our children. This is strange because all parents always want the best for their children. They send them to good schools, colleges, piano, violin lessons, leave a good inheritance, but they're also leaving a total environmental mess that their children and grandchildren have to deal with. I don't understand this.
네, 다음 질문 넘어가겠습니다. 철K님, 작년 한국은 50일 넘게 장마가 유지되었는데 이러한 현상도 기후 변화와 관계가 있는 건가요? 예, 답변 부탁드리겠습니다.
The 2020 extreme Changma season is not due to global warming. It was an event that occurred naturally. However, we have to say that as we increase CO2 concentrations in the atmosphere further, there will be more extreme rain in the future, in particular in summer and in Changma. So an individual event cannot be attributed to global warming, but if these individual events continue, this is a very good sign of global warming.
네, 다음으로 지금까지 이제 그 사전에 그 교수님께서 강연을 해주시면서 유튜브 채팅방에 남겨주신 질문 중에 이제 교수님이 그 선별하신 질문에 대한 답변을 지금 드렸고요. 마지막으로 이제 다시 한번 교수님 강의에 큰 박수를 한번 부탁드리겠습니다. 예, 그리고 저도 이제 하다가 보니까 질문이 좀 한 가지 있어서요. 답변을 좀 부탁드리고 싶은데, 지금까지 이제 기후 변화에 대해서 연구를 해주셨는데 우리 사회와 미래 세대에 혹시 당부하고 싶은 말씀이 있으실까요?
My message to the future generations is talk to your parents and tell them you don't want to grow up in a warmer world which will run out of food at some point. You don't want to grow up in a warmer world which will see mass migrations and loss of biodiversity. Urge your parents to take action and contribute to carbon neutrality. Urge them to become future responsible parents for the rest of the world. Thank you very much. 감사합니다.
감사합니다. 예, 지금까지 이제 과학기술정보통신부와 한국과학창의재단에서 준비한 실시간 과학 소통 시간이 이제 마무리됩니다. 여러분들의 의견을 토대로 더 좋은 기회로 또 찾아뵐 예정이니까요. 앞으로도 많은 기회와 참여를 부탁드리겠습니다. 그리고 중간에 한번 답변 드릴 때 중간에 하나 끊긴 게 있었는데 좀 양해를 부탁드리고요. 이상 4월 과학의 달 특집 사이언스 클래스 라이브 프로그램을 마치도록 하겠습니다. 같이 인사. 감사합니다.
감사합니다.
네.